Please notice that our next class, we will have a test. So we're going to look at applications again. We've kind of already looked at this, but we're just going to take one more look at it, and then we've got some practice to do today. So looking at this scenario, you've got Lily has her boat docked. We've got a little typo. Lily has her boat docked on the west side of Canyon Point. She is boating over to Canyon Marina, which is located directly east of where her boat is docked. So she's got her boat docked here. She's got her boat docked here, and she needs to go over there. Okay? The graph and the table model the distance she has to travel north of Canyon Point, where D is going to be the number of feet and T is the time traveled in minutes. So if given a table, we're just going to go ahead and enter it. They've given us a graph. We know it's a quadratic, so we don't have to go through the process of determining if it's a quadratic. We can go ahead and do our quadratic regression. So you'd clear your calculator, home one no, and then we're going to type in lists and spreadsheets. So we'll go to 4. Remember, we got to put in our X and our Y. And then you're just going to type your table in. So I'm going to type in all my X values. Be careful, make sure you type in each one correctly. You also want to make sure that all your X values match up with your Y values. You'll notice when you're looking at this table, sometimes you can see that it's a quadratic in a table because you'll see a change in direction. For example, you notice these right here, as you're going through your Y values, you go from 0 to 50, 63 to 68. These are all increasing, and then all of a sudden you start going back down, 65, 54, 8. So you see a change in direction in your table, and that can be a heads up that you might be looking at a quadratic. Not always the case, but in this case we have a graph and we're told it is. So at this point we've got it entered. We're going to go back up to our C1 block in our table, and we're going to type menu, statistics, stat calculations, and we know it's a quadratic regression, so we're going to do 6. We're going to put in our X, because that's where we put our X values. We put our Y values in Y, and then we're going to push enter twice. So in your calculator, it tells us to find the regression. So we have done that. Notice it's got A is negative 16, B is 66. So that means I've got Y equals negative 16x squared plus 66x. And then the C value is 0. And when you look at your graph, you'll notice, well, it does start at that point as 0, 0. So that's why you have a C value, a y-intercept of 0. Graph in the calculator, sketch the graph. So we have told our calculator what it is. Now we want to tell our calculator to graph it. To do this, we're going to hit Control, and we're going to do Dock to add a page. We're then going to do, we want to add a graph. And then you'll notice it's at F2. We're going to arrow up to F1, and we're going to push enter because there's our graph. Let me delete these little lines I drew. So that would be our graph, and you'll notice it matches what they have. So let's see, make sure to label the roots and the maximum as graphed in your calculator. So let's do that first. If we want to find the roots, we're going to do menu, analyze graph, and we're looking for zeros. Remember, our roots are called zeros, solutions, x-intercepts, and x-intercepts, what am I missing? Solutions, x-intercepts, roots, and zeros. I'm not sure which one I didn't say. You want to get to the left and the right of it. So one of ours is 0, 0, which that one we already knew. So we're just going to come over here and we're going to go ahead and we're going to label that point. Then we can go back and we're going to go find the other root. To do that, we've got to repeat the same process. Analyze graph. We want to find a 0. You want to click to the left of it and you want to click to the right of it. And so this one says 4.13. So we'll come over here and put in 4.13, 0. So let's see, next we have, they ask us to label the maximum as well. So to find the maximum, you're going to hit Menu, Analyze Graph, and you're going to go with Maximum. We know the maximum is off our screen up above, so we want to click to the left of it, and then we're going to click to the right of it, and then it'll pop up showing what our maximum is. So we can come over here and we can label it as well. It's 2.06, and let's see, we've got 68.1. So at 2.06 minutes, she is 68.1. That's her distance in feet, right, from where she had started. So then let's see, after that, what is the maximum distance north she traveled? Well, that would be our maximum, so we're at 68.1 feet. And then when did she reach this? Well, at 2.06 minutes. So we use both our X and Y value from our maximum to get those two answers. When will she reach Canyon Marina? Well, that's going to be her destination, which is over here. She's going to reach it in 4.13 minutes. State the domain for this situation. So the domain is going to run from over here all the way to over here. Since it is continuous, that means we're going to write this as a continuous domain, so we do less than x less than. Her time started at 0, at which time you would include because she was at her dock. And then she went all the way to 4.13 to reach her destination. Once again, that would be included because that point exists on our graph. We have to state the range. Remember, your range is your y values. So we're going to go from our lowest y value. Our lowest y value is going to be 0 feet, and that's included. That's when she's at her dock and or her destination. And then the maximum distance she reached was 68.1. And that was when she was furthest, she had traveled the furthest from those to get to the other when she's actually at the top of her point. She's got a little peninsula she basically has to go around, okay? So now going through these same skills, you're going to work on the classwork you have. You'll notice you'll be given a table. Rough sketches, keep in mind when you draw a rough sketch, we're looking for those points when we draw those rough sketches. We want both the roots and we want the maximum or the minimum in each case.